All right, ladies and gentlemen. This week, I'm gonna wrap some stuff up here. Um, First thing we need to look at. So last week we were dealing with triangles. We will come back to triangles here in a second, but you're gonna need to know a little bit about square roots in order to complete the rest of the triangle stuff. So, in terms of square roots, you guys have probably seen the symbol before. Square root symbol looks kind of funny, but either way, underneath it is what you're gonna take the square root of. Now, if I said, what's the square root of 2? Or I'm sorry, what's the square root of 4? Many of you would say 2. If I said, what's the square root of 25? You'd say 5. How do you know those so quickly? Why do those come out so nicely? And if I took the square root of 6, it's not going to come out so nicely. And what I wanted to show you is these numbers, for example, square root of 4, square root of 9, square root of 16. These are all called perfect squares, and they come out to be nice numbers. Everything in between does not. If you take the square root of 5, you're going to get 2.1 something. All right. And what I wanted to show you real quick is perfect squares actually make squares. And so what I mean is, so for example, the square root of 1 is also a perfect square. It's 1. Now check it out. If I have one tile, so whatever's underneath the square root, if I have one tile, it makes a perfect square. All right. What about the number 2? Does this make a perfect square? The square root of this is, if we say the square root of 2, does it make a perfect square? No. What about 3? That's a rectangle, by the way. It's not a square. 3 definitely does not make a perfect square. Even if I put it here, it's a rectangle. But what if I go to 4? 4 makes a perfect square. So it is a perfect square. So you can actually use literal squares to figure it out. Let's go. So the next one is 9. Can we make a square with 5 tiles? No. Nowhere that I put it. What about 6? Makes a rectangle, not a square. 7. No. No matter where I put it. 8. No. But the next perfect square is 9. Oops. Is 9. And you can probably guess the next perfect square that we have is not until we get to come on, until we get to 16. Next one would be 25. Next one would be 36. So we can literally use squares to come up with perfect squares. And there's your 16. All right, so that's one way to figure out what the perfect squares are. All right, now I just want to show you that real quick, but all you have to do here is, for what you're asked to do on the worksheet, is it says simplify each square root and tell me whether it's a perfect square. You just need to put it in your calculator. If you recognize that this is a perfect square right off the bat, great. If not, put it in your calculator. Square root of 81 is 9. Therefore, it is a perfect square. Same thing with 64. Square root of 64 is 8. Therefore, it is a perfect square. So first off, if you actually wanted to use this is part of our textbook. Here's our algebra tiles. Just go to blocks and you can use the green blocks. You can see I don't want to get 81 squares out, but you'll see if you make a square of 81, or if you take 81 tiles, you can line it up as a 9 by 9 square. 64 would be 8 by 8. Now square root of 200, again, I don't know if you want to get 200 squares out, but the square root of 200 is 14.14. You can keep it like that, just do it to 2 decimal places, but therefore, it is not a perfect square. Is not a perfect square. It comes out to be a decimal. That means that if we took 200 squares and tried to make a perfect square out of it, it's not going to work. There's nothing that we can do there. Square root of 73 is 8.54. You can round it to 2 spots, and therefore it is not a perfect square. So, and what's cool about this is that 9 and that 8, they represent the length and the width. So this right here, again, is 16. The square root of 16 is, what's the length and width of this square? It's 4 by 4. So the square root of 16 squares is 4 by 4. The square is 16, the length and the width is 4. All right, if I take away bunch of them. 9 by 9, the square root of 9 is 3. The area is 9, and the length and the width is 3. So when you're looking at this, 81, the length and the width is 9. It's a 9 by 9 square. It's an 8 by 8 square. You can tell these are not perfect squares because it would take 14.14 squares on the length and the width. That's not a perfect square. And you can round these. That's fine. Round it to the nearest 100th. These decimals go on forever. Just as a heads up, the square roots. Other than that,